Hi everyone, it's Kira Garfolo with Greenville Tech's Math 120 again. Welcome back. Today we're going to talk about section 1-1, our very first section, and this is going to introduce us to the practice of statistics. So, what is statistics? Why are we even here? So, formally, our textbook defines statistics as the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusion. So that's like a really big mouthful. I will never ask you to regurgitate that, okay? I might ask you to match it to its definition. It might be part of a fill in the blank or something like that, but I will never give you an open-ended, please define statistics, because even I have to read that verbatim, okay? But there are a few important aspects of that definition that warrant discussion. First of all, statistics is a science, okay? It changes, it's a process, and its results change as we get more data to inform it. Good science changes, and statistics is no different. We're also going to be handling data. So we're going to be collecting data, describing data, all of that summarizing of our data. We'll spend our first 2 units, for the most part, handling the data in that manner. Then we can move to answering questions. So this is making inference, and we'll do that in Unit 3. And what I mean by making inference is we're going to take information from a sample, which we'll define here in a moment, and make bigger generalizations to our population or that big group of interest, like we'll talk about here in a minute. Okay? So we're going to be using small sets of data to make big statements about bigger sets of data. And anytime we're making that guess, we can't be absolutely positive that we're correct. So we need to also put a measure of confidence on how sure we actually are that our guess is correct. And so in Unit 3, those last 2 bullet points will become important. So as I alluded to on the previous slide, we need to talk about populations and samples. So anytime we have the entire group of interest, we are going to call this a population. The population is that whole group we want to make a statement about. Anytime you see the word all, you can generally think about a population, okay? If you're talking to all students at Greenville Tech, you're dealing with the population of Greenville Tech students, okay? If we calculate some sort of numerical summary based on this population, so maybe we take the average height of all Greenville Tech students, then that average height is going to be what we call a parameter. So something that we calculate from all of the data in a population is going to be called a parameter. Now, why do we not just use these pieces of information that we do know for sure? If we know the average of all Greenville Tech students, then why would we need to rely on a sample ever? Well, very commonly, a population is not exactly practical or sometimes not even possible to get information from. So if you think about voters, all voters in South Carolina, for example, let's say that we're voting in a race for governor. Until election day, it's not going to be practical for you to get every voter's response. Okay, that's what the voting machines do. Instead, we tend to rely on a smaller subgroup of that population, which we will call a sample. So if we have a subgroup of that population, we have a sample from that population. Notice that the S's go together, okay? And if we calculate something like the average from that sample, then we have what is called a statistic. So populations give us parameters, they both start with P, and subgroups are samples, which give us statistics, which all start with S, okay? Now, the whole crux of inferential statistics, what we are going to be working towards for most of our semester, is that we are going to use that sample data to make inference about that population. Okay, that's what we're going to get to in Unit 3, and that's what you would be doing in further statistics courses. If you're a visual learner, this slide might be helpful to you. The population is that whole big group, and we can get a parameter from it. Whereas if we just take a handful from that population, we have a sample, which can give us a statistic. So let's talk about some examples here. You can pause if you need to think about it. But in the first example, I'm going to the registrar's office and I get a list of all enrolled students at Greenville Tech. I found that their average age is 24. Here, I am working with a population because I have said that I am working with a list of all enrolled students. That keyword all is there. You know everybody's age, and you calculated the average to be 24. Since we calculated that from a population, that 24 is a parameter. The next one, I perform a records review for 50 of Dr. Robinson's patients, and I find that 12% of them reported post-op complications. Here, I am working with a sample because I say that I have selected 50 of her patients. So that suggests that there's more than 50, and that 50 of them is not all of her patients, right? I'm just taking a sample of 50 of them. And since I'm dealing with a sample, that 12% proportion is going to be a statistic. Came from a sample, it's a statistic. Lastly, I examined pay records for all South Carolina public school principals, and I found that the range of their salaries is about $50,000. Here, I am working with a population because I have all principals, okay, all principals in South Carolina. Since I am dealing with a population, that range value is going to be a parameter, okay? So take a few moments, rewind if you need to, because these are going to be very important. Now, a lot of times in our course, we are going to be classifying variables in many different ways. The first way we're going to classify these variables is we are going to classify them into qualitative or quantitative variables. So in qualitative variables, we are talking about qualities or characteristics, okay? So think about eye color, hair color, gender, species, major, brand of car, brand of clothing, coffee drink, whatever, okay? That is a quality, it is just a characteristic. On the other hand, if we have a quantitative variable, you need to be thinking about the word quantity, okay? We are counting or measuring something. So weight, temperature, age, net income, the number of classes you're taking, all of those are going to be quantitative. If you can count it or measure it, you are dealing with something that is quantitative, okay? Now, if we have a quantitative variable, then we can further classify, okay? This doesn't work for qualitative, it only works for quantitative variables, so something we're counting or measuring. If we have that variable that we're counting or measuring, we can say that it is either discrete or it is continuous. So a discrete variable is finite and countable, okay? So there are distinct, hence discrete, values that variable can take on. I always think about counting, right? 0, 1, 2, 3, 4. The number of classes you're taking this semester, the number of leaves that are on a tree, okay? Decimals and fractions are not possible, okay? If I said how many petals are on a flower, you would say, oh, there's 8 petals on that flower. You wouldn't say there's 8.25. Because if it tore, it's still a petal bud, right? Small petal's still a petal. So anytime you see the number of, that's a pretty good indication you're going to be dealing with a discrete variable because you're counting something. On the other hand, we can have continuous variables, okay? And continuous variables have infinitely many possible values, okay? They are not countable because all of those individual in-between values are possible, okay? So if you think about temperature, if somebody comes into a clinic and has they don't necessarily have a temperature of 98 or 99, they could have a temperature of 98.76239, okay? Our thermometer might say 98.7, but that is because we are limited by the technology. If we have a very, very expensive thermometer, we can probably get a lot more precise. Anytime you're talking about speed, distance, weight, any of those things where decimals and fractions make sense, you are dealing with something that is continuous. Now, there's one other way to classify variables. So we've already said they could be qualitative or quantitative, and that quantitative variables can either be discrete or continuous. So we can also talk about all variables. So going very back, qualitative, quantitative, it doesn't matter. We can talk about their level of measurement. So the very first, very basic level of measurement is the nominal level of measurement. And a nominal variable is that qualitative, no order, just a quality like eye color, hair color, major, something like that, okay? Don't get thrown off by nominal thinking that it means number. It does not. It comes from the stem nom, which is actually name, Okay, so you're just talking about qualities here. Now, if we introduce a natural ordering to those categories, it could still be categorical, okay? We have an ordinal variable, okay? So if you're thinking freshman, sophomore, junior, senior, you're still not counting or measuring anything, right? So it could still be, something that's qualitative, but it has a natural order to it. Small, medium, large, dissatisfied, neutral, satisfied. Okay, something that has that natural order is going to be ordinal. So the big difference between nominal and ordinal is nominal doesn't have a natural order and ordinal does. Now the next two are interval and ratio variables. And I like to introduce those two at the exact same time because their main difference is just what 0 means on that scale. So in an interval, interval and ratio are going to be your quantitative variables. Doesn't matter if they're continuous or discrete, that's a separate issue to this. Okay, so either one can be either of those. But an interval variable, the 0 is somewhat arbitrary. From a mathematical standpoint, it's arbitrary. Okay, negatives exist. A ratio variable has a true 0 point. So think about it. Ratio ends in a 0. Okay, ratio ends in an O. Ratio variables have your true 0. So this means that when something measures 0, it's the complete absence of. Okay, so if we think about something like weight, if we weigh an item in grams and it's 0.0 grams, that means it's not there. There's nothing there. A perfect 0 means there's nothing there. There is no weight. There is no item. It cannot have a negative weight. Okay. Distance. If there's 0 miles, then that's 0. There's no distance. Speed. Things like that are going to be ratio variables. Interval variables aren't quite as common, but if you think about the temperature scales that we're used to working with, both of these are going to be interval scales, okay? Think about degrees Fahrenheit first. Think about 0 degrees. That's not as low as that can go. That can be in the negatives pretty easily, right? Same thing with degrees Celsius, okay? 0 degrees Celsius is not quite as arbitrary. It has a scientific meaning, that freezing point of water, but mathematically it's fairly arbitrary. We can have negative 10 degrees Celsius very easily, okay? Typically, when I talk in my class about interval variables, I'm going to bring up degrees Fahrenheit and degrees Celsius because they're the ones that most people are very familiar with and have that, kind of right off the tip of their tongue. Now, for those of you who have taken science courses and you have used, one thing that comes to mind is you've used the gas laws in chemistry. The very first thing you have to do with temperature is convert it into a different scale of measurement called the Kelvin. And the reason is that Kelvin is a ratio scale. So technically, on the interval scale, it only makes sense to add and subtract. Okay? In order to multiply and divide mathematically correctly, you need to have a ratio variable. I know that we say it, right? If it was 20 degrees last night and it's 40 degrees tonight, we say, wow, it's twice as warm out. Really, that's not correct, okay? Because that 0 point is meaningless. So when we talk about 2 times as much, that's really kind of mathematically unfounded. If we wanted to use the ratio scale like the Kelvin, we could talk about twice as warm or twice as whatever. But in Kelvin, 0 means absolute 0, so it is that ratio scale. Since it's a ratio where multiplication and division make sense, that's why we use it in science. Don't worry, I'm not going to ask you about Kelvin on your test because that's not something that everyone has seen, but many of you have seen it in a science class, and I wanted to give you a little bit of light as to why. Okay, let's practice here a little bit. So for each of these, what I'm going to say, is it qualitative or quantitative? And if it's quantitative, is it discrete or continuous? And also tell me about the level of measurement. Again, pause here if you need to make sense of it, but I'll just kind of talk through it. The number of parking spot spaces at Haywood Mall. Qualitative or quantitative? Well, here it's going to be quantitative because we're counting something. It's the number of parking spaces. Where quantitative is something that we count or we measure. Since it's quantitative, we can say if it's discrete or continuous. Here it's going to be discrete because we are talking about the number of, okay? We are counting those spaces. We don't have fractions of spaces, okay? We either have that space or we don't have that space. As far as level of measurement goes, we know that it's quantitative, so interval or ratio. And here it's going to be ratio because 0 spaces means there are no spaces. We can't have negative spaces. It has that true meaningful 0 point. Our next example is the variety of apple growing on a certain tree. Here we have a qualitative variable because we're just talking about a characteristic, okay? It is Red Delicious, or it is Fuji, or it is Honeycrisp, okay? That is going to be qualitative. We can't talk about discrete or continuous since it's qualitative, but level of measurement here is going to be nominal. I fully support that Honeycrisp is way better than Red Delicious, but there is no natural ordering here, okay? So we're just going to have it straight up nominal. There's no natural ordering, and it's qualitative. The temperature in degrees Fahrenheit of the Atlantic Ocean at a specific location in Florida. Here we are going to have a quantitative variable because we're measuring that temperature. It is going to be continuous because we can have all of those intermediate values. Again, we're just limited by technology. And here it is going to be interval because we are dealing with a degrees Fahrenheit scale, where 0 does not necessarily mean absence of. We can easily go into the negatives on degrees Fahrenheit. The orbit speed of the moon is definitely going to be quantitative because we're measuring it. It's also going to be continuous because we don't have just whole numbers that we're counting. We can have decimals, and NASA very much does get decimal estimations. Our level of measurement here is going to be ratio because 0 means 0. We can't have a negative speed. I know. If you took physics, you can have negative velocities. It just means you're going the opposite direction. But for the purpose, that's more of speed and direction, okay? Here, for the purpose of the speed, we are going to call it a ratio variable. Okay, that is all I have for 1-1. Make sure that you review your text and any other resources. And of course, you're welcome to ask me if you have any questions. Thanks for tuning in. Have a great one.